and welcome back to this lecture on Introduction to Data Analytics, the current challenges and the course outline. So in this lecture we'll be discussing on how we can transition into the field of data science and data analytics, what are the current outline challenges that we have to overcome, and what's the course outline that we have to expect in order to move further in the domain of data science. So firstly, we define the learning objectives of our course and a little more intro about the course, the outline of the course, definition, and why analytics is more than just analysis, what are the skills that are required, and what is expected. So whenever we are working towards a new field wherein it's a totally different sector from what we have been taught earlier, it's recommended to use self-assessment and assignments, which can be written or even oral as well. So we can take individual oral presentations with specific percentage and grade allocation provided. This could be a self-assessment, or guys and girls can also ask their colleagues to help them assess them for a competition like self-assessment test. There could be presentations depending upon the number of students, and participation in class, and late submission policy as well to make sure that everybody completes it on time. Mostly you can also use reading assignments which are needed to support key topics and to complete assignments. So will not be discussed much in class unless there are questions. You will perform mostly individual work. So it's you who wants to transition to data science, so you have to only take steps. So firstly, it's also a good idea to use some practical projects to make sure you learn little more new things while you are attempting a project. So getting your hands dirty or getting to some practical is a good idea. So we can analyze data from social networks, from Facebook, Instagram, and other like Twitter. So there are many public APIs or application programming interfaces which allow us to analyze data, and you can get around mostly with the student ID, and you can use those APIs for free for most of them. And the second one could be financial, where you can analyze stock market data to understand the patterns and see what's going on new in the market, and you can forecast the future. Social, economic, and marketing. So this is also a new domain, marketing, where data science, machine learning, and artificial intelligence are moving towards new heights. The fourth one being network and security, creating a firewall that's intelligent firewalls, and cybersecurity is another domain. Linked data, so data which you are already having on your system. Supposedly you're operating an e-commerce store like Shopify, or some other, like you're using say an in-and-out store, any outlets. You can also do analysis upon that. The last one being competitions, worldwide and local competitions as well. Any objective that's relevant to recognize and apply quantitative algorithms and techniques, and which could be used to interpret to some result or come to some conclusion, can be taken as relevant. And this is to help students develop some strategic and thinking skills combined with some solid technical foundations in data and model-driven decision making. Also to help them apply critical and analytical methods to formulate and solve engineering, science, and medical, or even business problems. So it's recommended to use for students to do it in groups, and as it will be easy to identify qualitative problems and apply content analytics. Also you can arrive at more creative solutions. It's also recommended to place data mining techniques in contests to develop data analytic thinking to illustrate that proper application is as much as an art as it's a science. So by the end of the course, you can assure that every and any student or candidate will effectively communicate analytic finding to even non-specialists. It's also important that a person from non-data science background should also be able to understand and interpret the meaning of your findings. Otherwise, it's all vague. So decision making about uncertainty, how to optimize the model, how to apply random parameters, stochastic optimization, two-stage optimization with recourse, chance, and constraint optimization. Also sequential decision making, weak models and mixed models. So once you get through the course, you will understand these terms, slangs, and other algorithms as well. So the learning objective through the lectures and practical sessions should demonstrate knowledge of relevant analytics method to recognize and apply quantitative algorithms and techniques and interpret results. So we should be able to demonstrate strategic thinking skills combined with some solid technical foundations in data. I think we have already covered that. So graduate students can be assessed at a higher level of demonstration, while additional questions or tasks in assignments are also recommended. Not necessary every time. So any questions so far, you can leave them in the comments section below. So firstly, we have to understand from which background are we from and where do we expect to end up. So the starting point and the ending point, and then we see how to fill the gap between. So supposedly you are from an arts sector, from creative arts or say commerce background, and you are looking to get into science, data science. So your origin point is where you are currently, and your final destination is where you want to be, and then we try to fill the gap between. And what do you expect to learn over there? That's also a question. And why are you here? That's the biggest question. So the nature of challenge in analytics, which we will see. So there are different kinds of analytics, reporting and processing, and even big data, which are divided into different sectors. So analytics deals with prescriptive analytics and predictive analytics. So prescriptive analytics involves automatically prescribe and take action, while predictive analytics involve a set of potential future scenarios. So reporting usually involve reporting services. If you guys have gone through the data warehousing, modeling and designing a data warehouse, that comes under reporting section. Identification of patterns and relationship in our data, which will end up towards an evolution of what has happened in the past, so we can predict of what might happen in the future. Processing data being prepared for analysis. It won't be every time the data is already in the most best form for analytics. Sometimes we have to filter our data or clean the data before it's being any analytics or business analytics techniques are being applied upon. That's called data cleansing. And then comes big data, from where we have to take the data, what's the source, where is the data going to end up, and how are we designing the data pipelines, etc. So containing containers and feeds of heterogeneous data. Then we access to the structured and unstructured data. So the three steps: tactical analytics, predictive analytics, and forensic analytics. So all of this communication happens over here in between these three. So 5 levels of decision support using analytics. So first comes information, then comes intelligence when we apply any statistical technique, and then we get insights from our modeling and optimization. So interestingly, people make decisions every day, depending upon the data, or not even depending upon data. They could be using computers to assist them or could not be using. Using computers to assist them might give them an edge over their competitors, because knowledge is power. Or if you have knowledge about what is happening, what is going on, you can take better actions to maybe prevent a disaster in the future. Gaining knowledge and how to use that knowledge, that comes towards data. From multiple sources we get information, then we use and combine that information, use some statistical techniques to analyze our data, and then we find some meaningful insights. Model is also a formula or an equation that could depend upon parameters or variables. So first we define the basic terms that we have been talking about, mainly the data. So data is the encoding that represent the qualitative or quantitative attributes of a variable or a set of variables. We are trying to define that. So data in plural means results or measurement or computations or observations that can be basis of graphs, images, or a set of variables. So data at the lowest level is defined as abstraction of which information and knowledge are defined. So the abstract from which we derive knowledge, which is essentially information. So firstly we are processing data into information. From the information we are deriving knowledge, and from knowledge we are deriving insights. And then comes big data. The volume, variety, veracity, and velocity at which data is increasing gives rise to big data, along with the value of the data. So anyone who wants to learn something about data analytics should take a road trip. According to IBM, Myriad's real-time decision must be based upon analysis of static information as well as ever-changing conditions. So data about traffic, weather, road construction, fuel, current location, or even available funds are just a few of factors. So this information and much more are needed to answer questions like, if I skip a gas station, will I run out of gas before reaching the next one? That requires data. What's the mileage of the car, and how many kilometers have you covered on the existing fuel, and how much more are we expected to cover until we run out of gas. So these require data. So is it worth driving 50 miles out of the way to see the Corn Palace? How late will that side trip make us? So that again depends upon data. So there are several case studies which we can use to enhance our skills, like sports analytics, marketing analytics, Amazon recommender system recommending you movies like Netflix. So analysis and the different software packages that we have are GNU R and RStudio, going from preliminary to initial analysis, parametric and non-parametric statistics. So we also come across a lot of around this term called statistics in data. So this has two common meanings which we want to clearly separate. These are descriptive and inferential. But to understand the difference between descriptive and inferential statistics, we must be clear between the difference of population and samples, which we are gonna cover in module 2 in this class. So then we come towards patterns, finding out patterns and relationships, or finding out correlation between the data. So these can be covered using data mining, classification tasks, clustering rules, machine learning, support vector machines, and non-parametric models. So outcome of these models are usually an evaluation of fitness for a purpose. So when we come towards prediction of a future event or even pattern, so we try to use applicable models, combining different models and the confidence level that we are having, multivariate models. Sometimes singular models don't seem to cover our demand for the data or demand for the solution which we are looking for. So choosing an appropriate model, combining different models, choosing the confidence level which can confidently predict the power to predict who will click, buy or lie or even die. So we can predict past events or even future events, patterns, etc. So prescriptions, we already had a discussion about it. So decision and effects, what should you do and why should you do that? We can consider these as business rules, benefit or mitigate or even adapt. Personal example, so builds on prediction, also involves scenarios and post analysis. So what has happened, why did it happen, what will happen, that's predictive analytics. How can we make it happen, that's prescriptive analytics. So we count these under optimization or foresight. So hindsight is information, insight is also moving towards optimization but in information. So to cover what we have covered, summary of what we have covered in this lecture. So through the stages of analytics, how we'll use current laptop installed data and some server data infrastructure for analytics to give you a practical experience, covering some algorithms, models and softwares on how to use them. A fast-paced course. Skills which would be required would be databases, data structures, literacy with computer and application that can handle the data we will use, pick up our programming, terminology, syntax and some refinement, ability to access internet servers, retrieve and acquire data, install and configure software, and presentation for proposed projects and assignment results. The projects that we were talking about: social media, financial, medical. So 5 to 6 assignments are more than enough to cover any field, so including differential calculus, statistics, optimization of a model, predictive and prescriptive analytics, data sets and data architecture. So attend classes, complete assignments, participate, you can ask questions, offer answers in class, work individually on assignments, in a group at your table, learn from each other, help each other, work constructively in online class sessions. So these are references for further reading and some other reference material. Hope you guys enjoyed this lecture. You can leave any of your questions or suggestions in the comment section below. Thank you guys and happy learning.